This is part 2 of chapter 25.6, Simpsons rule. And we're doing problems from page 764 in your textbook. I'm moving on to problem number 7 at this time. 7 shows us the integral of 0 to 5 of the square root of 25 minus x squared dx, and we are given that n equals 4. As always, our first step is to find h, or our increments, and h is equal to b minus a over n, which gives us b is here, a is here, so we have 5 minus 0 over n is 4, which equals 1 1/4 or 1.25, whichever you prefer to work with. That is our h. This is an important piece of information. Okay, so let's see what we start with. We start with our x of 0, and our x of 0 is always going to be our a, or our low value, which equals 0. So our y0 will be this value of x replaced into the function. So we would have the square root of 25 minus 0 squared, which equals the square root of 25, which equals 5. So our y0 equals 5. Let's go to a little bit darker color. Our x1 will be what we had before, 0, and add to it our h, our interval. So 0 plus 1.25 equals 1.25. So now we find y of 1, which is substituting 1.25 into the function. And we have the square root of 25 minus 1.25 squared. And use your calculator. You will get 4.84122, etc. And I'm going to take that to the nearest thousandth or hundredth and get 4.84 to the nearest hundredth, which you're not supposed to do, but I will allow you to do it because it's close. And these are ridiculously long problems. So x2 is equal to our 1.25 plus our next interval. Add another 1.25, which gives us 2.5. We know that we have to keep going because we're going all the way up to 5. So 2.5 is our next value that we will substitute in. So we get y2 equals the square root of 25 minus 2.5 squared, which is going to give you 4.330127019. So y2 is equal to 4.33. Now, because I am rounding to the nearest hundredth, my answer could very well be off by a few digits in the hundredths or tenths place. Okay, let's try x3. x3 is going to be equal what we had before, 2.5 plus our h, 1.25, and that is going to give us 3.75. So our y2 is going to equal to the square root of 25 minus 3.75 squared, which equals, hopefully you can't hear my dog, he's whining, 3.307189139, or y sub 3, another error here, y sub 3 is equal to 3.31. Okay, x4, let's see if we're going to get done soon. Take our 3.75 add to it our h, 1.25, which gives us 5. So y to the 4th is going to be equal to 25 minus 5 squared, which is the square root of 0, which is 0. Now remember, your first value and your last value, which is y4 equals 0, will be left alone when we evaluate them. We will not be multiplying them by anything in Simpson's rule. So Simpson's rule says that if we evaluate the definite integral from 0 to 5 of 25 minus x squared dx, it'll approximately be equal to, you have h over 3, which is 5/4 divided by 3, times, list your first value, 5, and then our next value has to be multiplied by 4 because that's part of Simpson's rule. So 4 times 4.84 plus the next value is multiplied by 2, 4.33, plus, and our last value, oh sorry, we have another one, we can multiply by 4. 4 times 3.31 plus our last value, which is 0, which does not get multiplied by anything. And when you work all of this out on your calculator, your answer should be 19.275. That's the approximate area under the curve. Now, let's go to problem number 11. Hopefully you're getting the idea of these. They're just really plugging in values and meticulously going through without making any errors. All right, let's try number 11. Number 11 says evaluate from -4 to 5. 2x to the 4th plus 1 to the 0.1 dx with n equal to 6. Oh, okay. So our h is going to be equal to b minus a over n, which is b is 5 minus, what is a? -4 all over n is 6. And that would give us 9 over 6, which is 3 over 2, which is 1.5. So h equals 1.5. Okay, so that's the first thing we need to keep in mind. That will be the values of our increments. Let's start with our x0. Our x0 is going to be our low value of a, which will be -4. So our y0 will be -4 into this equation. So we would have 2 times -4 to the 4th power plus 1, all raised to the 0.1, and that is going to give you 1.87 rounded to the nearest hundredth. Our x1 will be -4 plus our h, 1.5, and that will give us -2.5. So we need to evaluate -2.5 into this equation. So our y1 will equal 2 times -2.5 to the 4th power plus 1 all raised to the 0.1, and this will give you 1.55. x2 will equal what we had before, -2.5 plus our h, 1.5 equals -1. Notice we have to go all the way up to 5 here, so we got to keep going. So our y2 is going to equal 2 times -1 to the 4th plus 1 raised to the 0.1, which will equal 1.12. x3 will equal our -1 plus our h, 1.5, which equals 0.5. So y sub 3 is going to be 0.5 put into the function, which is 2 times 0.5 to the 4th plus 1 raised to the 0.1, which will equal 1.01. These little marks here. Let's go to x4. x4 will equal our 0.5 plus our h, which is 1.5, which equals 2. Let's evaluate the function at 2. So we would have 2 times 2 to the 4th plus 1 raised to the 0.1, and that will equal 1.42. Okay, x to the 5th, or our x5 is going to be equal to 2. I'm continuing over here. Is going to equal to, let's erase that and make that look a little bit nicer. 2 plus the 1.5 equals 3.5. Still have to keep going till we get to 5. So our y to the y sub 5 is going to equal 2 times 3.5 to the 4th plus 1 raised to the 0.1, which is 1.77. Our x to the 6th is going to equal 3.5 plus our h of 1.5, which finally gives us our top value of 5, so it's our last one. Yay! So y6 is going to equal 2 times 5 to the 4th plus 1, all raised to the 0.1, excuse me, equals 2.04. So y6 equals 2.04. All right, we have a few answers here that we're going to have to put into this mess. So our integral from -4 to 5, hopefully we have enough time left. I have 1 minute left, of 2x to the 4th plus 1 to the 0.1 dx is approximately equal to 1.5, which is our h over 3, because that's the formula, times our first value, 1.87, left alone, plus 4 times our second value, plus 2 times our third value, plus 4 times our next value, plus 2 times our next value, plus 4 times our next value, and plus our last value of 2.04. And all of this you should approximate to 13.155. Your book answer is actually 13.147 because we rounded up. Or I'm sorry, we rounded to the nearest hundredth. So that's how you approximate your, and this is close enough to me for our purposes. We found the approximate area under the curve between -4 and 5 by using Simpsons rule. I hope this video has helped. This will be the last one in this section. If you need additional help, please let me know, and we can do some possible Zoom time.